13.8 billion years. That number gets said so casually in documentaries, in textbooks, on school posters, and every time I hear it, a small part of me thinks, hang on, how would anybody know that? Because nobody counted. There is no cosmic birth certificate. What we have is, well, three separate inferences that happen to agree. The agreement is the whole argument. So, three clocks. The first clock is the expansion itself. In 1929, Edwin Hubble noticed that light from distant galaxies is stretched towards the red. The further away a galaxy sits, the harder the stretch. Simplest reading. Everything is moving apart. Space itself is getting bigger. So run the film backwards. Everything gets closer, and wind it back far enough, it all piles into one point. Take today's expansion rate, divide 1 by it, roughly 14 billion years. The Hubble time. But, and this is the part that usually gets skipped, that calculation is wrong. It assumes the expansion always ran at today's speed. It did not even close. For billions of years, gravity pulled everything back, so the expansion was slowing. Then, about 5 billion years ago, dark energy took over and it started speeding up again. So you cannot just divide. You need the whole history. Which brings me to the second clock, the precise one, the cosmic microwave background. Oldest light there is, released when the universe was about 380,000 years old, when things cooled enough for atoms to form and the fog cleared. That light is almost perfectly smooth. Almost. There are hot and cold patches, 1 part in 100,000, and those patches are frozen sound waves, pressure waves, rippling through the early plasma when the light broke free. And here is the trick. We can calculate how big those waves should have been. So we know their true size. We measure how big they look in the sky, and comparing the two gives us a ruler stretched across the observable universe. The Planck satellite mapped that pattern to extraordinary precision. Feed it into the standard model of cosmology, 6 numbers. That is all it takes. And out comes an age of 13.8 billion years, good to about 1%. Now, one honest caveat. That is a model-dependent clock. It does not read the age off directly. It reads a pattern, and a theory converts that pattern into a number. If the theory is wrong somewhere, so is the number, which is exactly why the third clock matters, the stars themselves. A star's lifetime depends on its mass in a very predictable way, and the oldest stars in our galaxy, almost free of heavy elements, must have formed early. This got sharper just recently. In July 2026, a group led by Indranil Banik in Portsmouth went through 155,600 subgiant stars using the Gaia satellite and the Chinese LAMOST survey. Their oldest come in at 13.73 billion years. Add the couple 100 million years it takes for the first stars to switch on, and you land on 13.8 from stellar physics alone, a clock that knows nothing about the microwave background. That is the real reason to trust the number. Not one measurement. 3 from completely different physics, landing in the same place. Now, the honest part. There is a crack in all this, and it is getting worse, not better. The Hubble tension. Measure today's expansion rate locally, with nearby supernovae calibrated by Cepheid stars, and you get about 73. Infer it from the microwave background, about 67. That is a 9% gap, far too big to be an accident. Everybody assumed the James Webb Space Telescope would settle it. Sharper eyes, less dust. Webb looked at the same Cepheids and said, "Your measurements were fine." It did not fix the problem. It confirmed it. And this bites on the age. If the faster local rate applied across all of cosmic history, the universe would come out at 12.5 to 12.9 billion years. Younger, uncomfortably close to the age of its own oldest stars. Which is why the stellar work matters beyond just confirming things. The stars say the early universe was, normal. So whatever causes the tension is probably late time, something recent. Maybe dark energy behaving oddly. Maybe we sit in an under-dense patch of space. One misconception worth clearing up. The age is not the size. The observable universe is about 46 billion light-years in radius, not 13.8. No contradiction, space kept stretching while the light was in transit. So, one picture to keep. 3 clocks in 3 different rooms, built by people who never spoke to each other. One runs on expanding space. One runs on frozen sound. One runs on burning hydrogen. And they all read, give or take, the same time. That is what 13.8 billion years actually means. Not certainty. Convergence.